Ladies and gentlemen, sorry for the break that we are just starting. Though we are back online, fully now, fully. No more breaks, no more, no more gaps. Okay, now so today we shall be working on mathematics. Now, while the last class we studied that formula method, quadratic equation, and that simply is a restart all over again. So, in case you don't really get it there, I think this is an opportunity for you to understand how to prove and apply quadratic formula. To do justice, how to prove and apply quadratic formula. That's just it. And what's the quadratic formula? The quadratic formula, let's just put somewhere here, states that x equals to minus b plus of minus root b squared minus 4ac all over 2. That's the quadratic formula, and that's what we're proving. And we'll be solving just maybe a question or two to buttress the point. Okay, so let's start. We have something called general quadratic equation, right? General quadratic equation, which is what? Ax squared plus bx plus c equals to 0, right? So we will use the same formula to prove it. Now we have three types of roots. We have the quadratic root, we have the real root, we have the real or distinct root. This is when the is greater than 0. Because when greater than or equal to 0, or the place where it is not just equal to, this is when we have a perfect root or an ideal root. The last one is just an imaginary root, which is when my determinant is less than 0. So probably we'll be dealing with these two. So, but for this class we'll be dealing with that. So probably if next class we can come up with this, then you can check out the reason why we have very perfect and imaginary roots. Okay, so let's start from here. We have rules that guide this, and the basic proof for doing this is just, this method is just a formula method. The basic proof for proving it out is using the completing the square method, in which there are rules to follow in solving by completing square method. I gave in the previous class. You can check how to solve using the completing square method quadratic equation. You can check out my next class for that. Okay, now same way I'll be following the steps now to prove it out. The first rule states that make the coefficient of x squared equals to 1. What do you mean by coefficient? Coefficient is the number behind an unknown variable. For instance, if you are given 2x, this 2 is the coefficient of x. If you are given b cube, there is an invisible one here. This one is the coefficient of b cube. So now in this case, we have to make the coefficient of x squared equals to 1. So what's the coefficient of x? So the coefficient of x squared here is equal to a. So making it equal to 1, we divide all through by a. So a removes a, and I have my x squared plus bx over a plus c over a equals to 0. The next one now says we should transfer our c to the other side. That's our constant. I have my x squared plus b over as equals to minus c over a. So the third rule states that multiply. Let me write that. Multiply the coefficients of x by half and square the result. So what's the coefficient of x? B over a, multiply it by half and square it, which is equal to b over 2a all squared. The fourth rule states that what add the results to both sides. So now what's there? I have my x squared plus b over ax equals to minus c over a. I add this to both sides. So we're having x squared plus b over ax plus this b over 2a all squared all squared equals to minus c over a plus, we add it again, b over 2a all squared. So now from here, checking at this is a perfect square. Now knowing a perfect square, I will explain that perfectly when we get to this. So if you don't want to miss this, we meet in our next class. Okay, so now how to know if an equation is a perfect square. There's a way you know, very fast method. It's just the way. So if I want to determine if a quadratic equation is a perfect square or the quadratic expression is a perfect square, there is a method for doing that. Okay, now let's move on. So now, knowing this, as usual, if we are to, this is the quadratic equation on its own, because we have x squared here, b over ax here, then this. So whenever an equation, quadratic equation expression is a perfect square, there is a formula I designed for that, and the formula is this. Formula is that, open brackets, you have the coefficients, or better still, how do I want to state the formula? Okay, let me say a, that is a, okay, ax plus, okay, it can be plus or minus, okay, depending on what you have on your b, okay, so I can now plus or minus, then plus c all squared. So that's the formula I just, so this formula is used to solve, this formula is used to solve a perfect square. So if you are sure, I told you we know how to check in this class, okay. So now once you've checked if it's and once you've gotten the perfect square, there's a way you can easily factorize it using this formula. That's all. Okay, now so here I can apply the formula. What's my a? My a here is 1. So I can now have my what? 1x, which is still x, isn't it? Now my b is positive, so I'll be using plus here, right? Square root of, what's my c? My c here is b over 2a all squared. Then everything squared, isn't it? So equals to, I can break this down and simplify, plus I'll be having b squared over 2a all squared. So now from here, this square cancel this. What do I have left? I have x plus b over 2a equals to minus c over a plus b squared over 2a all squared will be what? 4a squared, which will be having 2 squared times a squared, and 2 squared is equal to 4. I hope that's clear already. Okay, now, so now from here, I want to make a set of formula. Okay, I will simplify this, and let me simplify completely the right hand side over 2a. So simplifying, what's the LCM? The LCM is 4a squared. 4a squared divided by a. I have my 4a. 4a squared divided by a equals to 4a. 4a times minus c, I have minus 4ac plus 4a divided by 4a squared is 1. 1 times b squared is equal to b squared. So now I can make a set of formula by saying my x equals to minus b over 2a. I know I missed something. Thank God I got it. Okay, I forgot my square, so please be mindful when solving those, so you don't make that silly mistake. So now I've gotten this. So let me just rearrange the right hand side, so I can have x plus b over 2a all squared equals to, let me arrange it, b squared minus 4ac all over 4a squared. So now, whenever a square is transferred to the other side of any equation, it becomes square root. Or better still, we can say square root of both sides. You get it? Or square root both sides is just the point to square root both sides. And whenever it is transferred, on the other side, the root carries plus or minus. It is bound to be like that. Okay. So now let's move on. So now I can now say I've cancelled my rooted, so I'll be having what left? X plus b over 2a left equals to, here I'll be having plus 1. According to the law of sum that says root b over a will become root b over root a. This becomes splitted. You can split it. Where is division or even multiplication, you can split it. So now, same thing I'm applying here. So root b squared minus 4ac, right? All over root 4a all squared. So x plus b over 2a equals to plus or minus root b squared minus 4ac over root. Here I can have my 2a all squared, I think, because 4 is a perfect square also. So that my square can cancel this root. So I'll be having x plus b over 2a equals to plus or minus root b squared minus 4ac over 2a. So making use of the formula, this comes here. So my x will become minus b over 2a plus or minus root b squared minus 4ac over 2a. So I do for the LCM. Equal denominator, it brings about the sum or subtraction of the numerator. So same thing I do here. So we have minus b plus or minus root b squared minus 4ac all over 2a. That quadratic formula. So this is just quite easy now. So that's about just the proof, and that's all. Just as simple as that. So see, this is what we call the formula method. This is how it is gotten. So the formula method is extracted using the complete square method. So the part in which we passed in solving using complete square method, the same part we use in solving. So that's the reason why most times when your teacher is teaching class, substitution and complete square method is being taught first before the formula method, because it will actually be used in proving it. So that's that about it. Let's just solve one question from this, then we'll meet in our next class for real roots, understanding what real roots is. So let's just solve the question. So I will give you less than, okay, I'll give less than 10 seconds to write down the question, less than 5 seconds rather to write the question, so that you can just listen and come along with me. Okay, so the question, let's assume we are having 2x squared. Okay, 5 and 2 plus 10x plus 5 equals to 0. Now given a question like this to solve using formula method, the first thing you do is fix out your a, b, and c. So your a is the coefficient of x squared, your b is the coefficient of x, and your c is your constant. So my a equals to 2 plus 2, right? So my b equals to 10 and my c equals to what? 5. So now what's the formula? S is equals to minus b plus or minus root b squared minus 4ac all over 2a. Let's just substitute. It's just as simple as that. What's my b? My b is 10, so I'll minus 10 plus or minus is 10 squared, right? Minus 4 times. What's my a? My a is 2 times. What's my c? My c is 5. Okay, sorry. Then I made this minus 5. That my c becomes minus 5. Minus 5. Okay. All over 2 times. What's my a? Is equals to, so my x equals to minus 10 plus or minus root. Okay, don't worry, let's make it positive 5 plus 5. Okay, so now I have 10 squared is equal to 100 minus 4 times 2, 8, right? 8 times 5 is what? 40. I think, yes, is equal to 40. So all over 4. So my x equals to minus 10 plus root 100 minus 40 is 60. So root 60 is equal to, and 60 can someone help us? Let me say 7.67 over 4. Let's confirm that using a calculator. Okay, now we're back. Sorry for the break. So I'll be having root 60. Root 60, okay, 7.75, right? 7.75. 7.75. So I can now split the plus or minus. So minus 10 plus 7.75 all over 4, or minus 10 minus 7.75 all over 4. So you can now have x equals to, so 7.75 minus 10 will liberate, will give us minus 2.25 all over 4. Let's confirm that also in our calculator. Okay, we are correct, minus 2.25. Then this will be a minus 17.75 all over 4. So now let's divide. So this divided by 4, 2.25 is equal to 0.56. 0.56 minus 0.56 rather, or minus 17.75 divided by 4. I have 4.44 approximately. Okay, approximately, and we are these are the values of our x. So normally we are known in quadratic equation are known to have two roots. So it is equal to alpha or beta. So I can now say my alpha equals to minus 2.25 and my beta equals to minus 4 points. Sorry, minus 0.56. Yeah, that's what. Okay, that's all. So thank you very much. Next class we meet about real quadratic. Thank you very much. Don't forget to subscribe, like, and share. With your friends, family, your classmates, everyone. Then you find out just if you came at this. It's a platform where you can learn anything, and any comments drop it below. Thank you very much.